All right, here we go. We are taking areas of regions and we are spinning them. Okay, spinning them around axes, spinning around different lines. And we're going to calculate the volume of these objects. And it all comes down to formulas for volumes of cylinders. The volume of a cylinder, its formula is pi r squared h. Okay? What we're going to be doing is we're going to be taking our skinny rectangle that we've been using to find areas, and we've been using the formula of base times a height, or a height times a width, or width times a height, and we are now changing it because when I take this skinny rectangle, I want to draw a good skinny rectangle here. That's good. And spin it, okay? Here is my skinny rectangle being spun. So here's the reflection when it spins down here. Like here is top, bottom. Okay? Now, R is right here. R ends up being the height of the rectangle. Whereas H right here ends up being the skinny width of the rectangle. So H in our formula, this H, here's the height of my cylinder, but this ends up being the width of the rectangle. And in this case, since it's infinitely skinny, the width is a small change in x. Now if I take a skinny horizontal cylinder and spin this, see, its reflection is coming over here. And you got the top here. The bottom. It's the same deal. Here's the radius of my cylinder right there. The radius in this case is the width of the rectangle, an x distance. You know, a right minus a left or something. And then the height in this case is the height. And this is, in this case, if it's an infinitely skinny horizontal rectangle, a small change in y. Okay? To find the volume of a rotated area, we are going to take an infinite sum either from left to right of pi r squared h's for this situation. H is dx, r is my h, it's like my top minus my bottom. To get the top, we need y coordinates, which means we need an equation of x's. Okay? Or we're taking an infinite sum from a bottom to a top to ensure that the heights of these cylinders are going to be positive, of another pi r squared h, here times h is dy. R is going to be a right minus a left, but they are x distances, so we need equations with y's. Okay, that's it. Let's do it. We're going to rotate this area around the x-axis. I like to picture it, and I like to draw my cylinders. Here is my cylinders. should be starting over here. Here are the radiuses. I like to make sure I can see my radiuses by kind of denoting here. It's not super important here. Now, we'll take an infinite sum of pi r squared h. Here, the height of my skinny cylinders is going to be a small change in x. The radius, I guess I should put that down here. The radius is the height, the y-coordinate, which is coming from a function of x's, an equation of x's. So I got 9 minus x squared. I need to go from a left coordinate to a right coordinate, so it's definitely 0. On the right coordinate, I need to set 9 minus x squared equal to 0. I get x equals 3, so I should be able to figure out this is 3. Okay. Now, if you were to do this by hand, you would have to distribute some stuff. And you'd have to say pi, and you could actually pull the pi out. So just pull the pi out. And then you'd have to distribute this out to get 81 minus 18x squared minus x to the fourth. And then you'd have to take the antiderivative. And sometimes there will be certain situations where, like, you have to do this. That's x cubed divided by 3. The 18 divided by 3 is 6. This is 1/5 x to the fourth. And you're finding the change in this between 0 and 3. Like, you'll have to do this sometimes. Calculator, just type it in. For most situations, you will just be doing this by calculator, okay? But I want you to be, wary that, like, there are some situations where you're going to be asked to do it by hand. And if you are asked to do it by hand, you need to go ahead and distribute things. You can't take the antiderivative of the outside because the inside is not an ax plus b, it's an x squared. It's just kind of like what we did last unit, talking about when we can't use, when we can and when we can't use substitution. So we need to be ready for this, but for most of the times we'll be doing this. So I need to, practice typing this stuff in. And there's two ways we can have the answer, and we need to be prepared to write the answer in two different ways, either with kind of like the pi factored out or with the pi in place. So either we have the pi, so I got math 9, 0 to 3, pi, and then 9 minus x squared, quantity being squared, dx. Okay, so either it's going to be 407.150, or we will leave the pi out and then just say it's a multiple of pi, this multiple times pi, because it's a constant. We can pull that pi out, so 129.6 pi. And that's what we would have gotten if we actually calculated this. All right, now if we revolve this around the y-axis, here's the y-axis, here's what my revolved region will look like. And I can see I have these cylinders that I need to sum up. And I notice that cylinders are going to be horizontal. When you're revolving a vertical axis, it's very advantageous if we use we have to use a horizontal rectangle that is revolved around a vertical axis. So we have to use this horizontal situation. I like to denote my radiuses. So here are my radiuses. They end up being widths. Which is going to be an x equals y equation. I'm going to have to solve this for x. I got y minus 9. Actually, it's probably 9 minus y is easier. Add the x squared. Subtract the y. I have x squared equals 9 minus y. And then I take a square root. I should have a plus or minus for this, you can see we're kind of on the positive side of things, not the negative side of things. The negative side of things would be over here, the negative 9 minus y. So that is my x distances. Okay? And then my height of my skinny cylinders is a very, very small change in y. So I'll take an infinite sum of my pi r squared h's, h being dy. R squared is root 9 minus y. And then my sum is from 0, from a bottom to a top. I got to figure out when x is 0, y is 9. I got to go from 0 to 9. It's very, very important that we make sure that these boundaries are correct and that we're not just focusing on just like always left to right. Here, if we're talking about making sure dy is positive, I got to be going up, bottom to a top. Now again, we need to be ready to do this by hand, which means we should simplify. In this case, it actually works out kind of nicely. After I pull out the pi, I could square the roots, and it's just 9 minus y. Calculator, you'll just type it in. But let's kind of just actually do the calculations here. I'll have 9y minus 1/2 y squared. That's the antiderivative with respect to y. 0 to 9. Let's worry about that pi later. I'll get 81 minus 81 halves. So that's 192. It's going to be 81 halves. 81 halves pi. Calculator, we'll see, we'll either get 81 halves pi or we'll get the number with pi plugged in. So math 9, 0 to 9, pi. I mean, you could type in the root if you want to, but you know the root 9 minus y squared. It's just going to be 9 minus y. And that is the same as 81 halves pi. This is 81 halves pi. Okay, so calculator, you either get 127.234 or 81 halves pi. All right. Well, we need to be prepared to rotate things around different axes. Like here, I'm rotating y equals root x, and x, this region, y equals 0, x equals 4, around the line x equals 4. So here would be my reflection. It helps to draw this reflection and to draw your cylinders. Just like I told you to draw your rectangles, now we're drawing our cylinders. Notice a vertical axis means I need to use horizontal rectangles. Now, what is my radius? I could go from all the way over here to the middle, but I kind of don't know what this equation is. I do know what this equation is. This is y equals root x. So here to here is my radius. Here to here is my radius. Here to here is my radius. So that's an x distance. That's a width. My width, x distance in terms of y's, well, this x distance is 4. It's always this right line, this x equals 4, minus this x distance. Well, this x distance, I have x would be equal to a y squared distance. So this would be 4 minus y squared. The height of all these cylinders are very small, and it's a very small change in y. So this width is the radius. I'm going to take an infinite sum of my pi r squared h's. The h's are dy in this case. It is the actual height of the rectangles. And the r is going to be 4 minus y squared. I'm summing this from 0 to when x is 4. This y is 2. We got to figure a bottom to a top. So it's not going to be 0 to 4, it's 0 to 2. Make note of this. This is where students like struggle. They like to put all the numbers that they see in you know, the integral, but the 4 is actually a right minus a left. And again, you can distribute this. I'm just going to show this one more time, because there's some situations where you'll be forced to, depending on the question. Do an integral from 0 to 2 of 16 minus 8y squared minus y to the 4th. You'll have to take the antiderivative. Plug in 0 and 2. I'm not going to spend time doing that, whatever this is, or using your calculator, you're just going to type this into your calculator. Okay, 53.1.616, or take this pi out, and then just don't forget about the pi at the end. That's probably a nice fraction. Okay, not that nice. 256/15 pi's. Without a calculator, find the volume of the previous area revolved around the x-axis. All right, so we're now definitely using no calculator. We have this region here, revolved around the x-axis. It pops in down here. And here are my cylinders, right there. And here are my radiuses. The radius is going to be a top minus the bottom. It's just going to be the height. The bottom is a 0. The height is the y distance in terms of an x equation. So y equals root x. So whatever your x coordinate is, you plug in a root x, you get the height minus 0. The width, the height, sorry, of the cylinder is the width of the object, which is a small change in x. We'll take an infinite sum from of my pi r squared h's. My h is dx in this case. My r is root x. I'm taking an infinite sum from a left coordinate to a right coordinate. So from 0 to x equals 4. You can do this easily without a calculator because root x squared is just x. Take the antiderivative. You got pi times 1/2 x squared from 0 to 4, which is going to be 16 over 2, which is 8 pi. And just to confirm, math 9, 0 to 4, pi times root x squared, it's just x. You get 8 pi. Okay? How to calculator, find the area enclosed by y equals x squared, y equals 0, x equals 2, revolved around the x-axis. Okay, so let's see this. X squared, y equals 0, x equals 2, revolved around the x-axis. Okay. Here are my cylinders. Here are my radiuses. The top minus the bottom, but the bottom is 0. So this is pretty simple. They are vertical rectangles. So the skinny height is a width, which is a dx. The radius is the height, which is a x squared value. Infinite sum from a left to a right, 0 to 2 of pi r squared, so that's x squared squared dx. We're doing this without a calculator. Great. So I got to go pi x to the 4th, 0 to 2. So I get pi times 1/5 x to the 5th from 0 to 2, which is pi times 2, 4, 8, 16, 32, 32/5 pi minus 0. Guaranteed that's the same thing. Let's revolve this region around the x equals 2 axis. So here is my region. x equals 2. Well, x equals 2 is this line that is already given to us. But now if I revolve it around this line, I'll pop over here. It's very important to draw your picture. We're revolving around a vertical axis, means we need to use horizontal rectangles being spun. Here are my horizontal rectangles being spun. The radius is right here. From here to here, these are the lines that we know. The radius is a width in this case. It's going to be x distances. The x distance is a right minus a left. It's going to be 2 minus. I'd have to solve this equation for x. Solving for x, I get x equals root y. So I got an infinite sum of pi. My radius is 2 minus root y squared. My height of my cylinders is a small change in y. It's the height of my objects, height of my rectangles. So the height equals the height, which is a small change in y. That's dy. I'm going to sum them up from a bottom to a top. The bottom value is y equals 0. The top value, if x is 2, this y coordinate would be 4. Okay, now I'm going to, for most of the other ones, just leave our integral and assume you guys know how to plug it in, or assume you know how to distribute. Oh, they're asking us to do this without a calculator. Never mind. All right, here we go. Pi. I have to distribute. Okay, it's like messy, but we'll see. We're going to see some problems where you're going to have to do that on the AP test. I just saw the most recent practice test that was produced. You have to distribute, and it's a little tricky. Kind of like this one is. So I got 4y minus, this is y to the 3/2 times 2/3, so that's going to be 8/3. Oh, I don't want to do this. I'm probably just going to leave this like this. Now, I mean, I guess a good example of like free response questions, you don't need to simplify. You can't leave it like this, but you can just leave things like this: 16 minus 8/3, 4 to the 3/2. I could figure out what that is. It's going to be 64/3 plus 16 divided by 2, and then minus 0. Leave it like this. We are done on the free response. You don't have to simplify things. As long as you have a unsimplified numerical answer, it's totally fine. All right, those are all solid objects. Okay, great. Solid objects, pi r squared h, cool. But now we're dealing with objects with holes. Right, 2 different ways to find the volume of this area spun around the x-axis. Well, unfortunately, I did not do you a favor by giving you enough room to kind of show the reflection, so we're going to have to just do the best we can. Here is the region reflected, okay? Now, what we find is that to find the volume of this entire object spun, we realize we have some negative space here, like a hole. What we need to do is find the volume of everything and then we're going to subtract the volume of the hole. Okay? So what I like to do is now bring out 2 sets of cylinders. I got my red ones, which will represent the entire object. So it's getting everything, including this negative space, if I add up all of these cylinders and their volumes. Here are the radiuses. Okay, it's going to be that 3x as the height. It's the radius. But then I have these cylinders here, which will represent the hole. And I need to subtract out these blue cylinders. And these blue cylinders are going to be my holes. So I'm just going to make sure you guys see the volume of my hole is going to be in blue. The volume of my entire object is going to be in red. So we could either do 2 separate integrals. We got an integral, we're going to have to figure out where x squared and 3x intersect. It's going to be intersecting at 3. So 3 squared is 9, 3 times 3. So we're going to go from 0 to 3, a left to a right. Pi, my r is going to be my height. My h is a small change in x. My r is going to be an h. It's going to be, in this case, 3x. So pi 3x squared h. And the 3x is what the red cylinders are going to. But then I will subtract the volume of my hole. So this is going to be 0 to 3 again, but pi, the radiuses of my blue cylinders right here are going to x squared. It's an x squared minus a 0. It's a top minus a bottom. I don't have to worry about subtracting any numbers because it's just top minus a bottom of 0. So I'm not putting a minus. And then this is dx. Now what we can do, and this is how we kind of come up with the formula for the volume using a washer and the volume of a washer, is if you factor out the pi, if you factor out the dx, you will have just one integral where you're just going to have the outside radius squared minus the inside radius squared. So 3x and then x squared. I kind of prefer students to go with this technique. This is what I will, star, because I think you do a better job of just remembering pi r squared h and just sticking with this. And when students do this, I see a lot of mistakes. I see if they try to memorize this, they memorize it wrong and they do pi 0 to 3 of 3x minus x squared squared. And that's not correct. This is not the same. If I had to square this, it's not going to be 9x squared minus x to the fourth. So don't use this form only if you really understand it. You need to know it. You need to be able to use it. There will be some questions that require you to put it in that form, but make sure you understand it before you use it. That's what I'm going to say. Okay, and this should probably be in parentheses. All right. Now, we are going to start revolving things around different axes. And we shouldn't be intimidated so long as we draw pictures and draw cylinders. Okay, so now I've got y equals -2. So y equals -2 is down here. So when I revolve this, I'm going to have my curve here, and then my straight line there. It's going to be on the outside. Draw two sets of cylinders, one going to the entire object, the outside, and then the other one doing the hole, the negative space on the inside. Denote your radiuses. Well, here's my radius. Here's a top minus bottom distance. Top minus bottom. And here my radius is here. It is also a top minus a bottom. It's going to the y equals x squared. Okay. I'm not going to bother plugging stuff into the calculator now. I'm just going to write the integrals, but it's up to you to be able to plug stuff into your calculator. So I got two different ways. Object minus the hole. My object, again, it's vertical rectangle, so I'm summing them up from a left to a right. They intersect at 3. So 0 to 3. I got a pi r squared h. Here's my object. My object in red, these radiuses now are a little bit adjusted. It's a top minus a bottom distance. Well, the top is the 3x, but the bottom is a -2. So I'm like adding 2 to expand the radius. It's larger than just 3x. Okay, top minus bottom. And then I will subtract. 3x integral from 0 to 3 of pi. My blue holes, my negative space, its radius is going to be a top minus a bottom. The top is x squared. The bottom is also -2. That's being squared, dx, or factor out the pi, factor out the dx. You just have one integral. You have the 3x plus 2 squared minus the x squared plus 2 squared. Okay, now we're revolving this around the y equals 10 axis. Now we're up here. And this is where things get tricky. Okay, so it's not going to be easy to see, but watch what happens here. This is where everybody messes up. Let's look at the outside. The outside, which will give me my entire object, is actually going to the x squared. Here is the outside radiuses. I'm using these two because I know what they are. I'm not going to use any of the dotted lines because I don't know that equation. And then the blue guys, the inside, is actually going to the line, the 3x. So here's my inside. Okay, ready? Here we go. Object minus hole. My object, again, left to right, because they're vertical. Object is pi. The r, in this case, the red r's, which are these heights, are a top minus a bottom. That is a 10 minus the x squared. X squared, even though it's on the bottom, it's not. It covers my entire object, these red cylinders. So this is important. That's why I draw things. If I just kind of like try to get the answer quickly, you're not going to be able to get it quickly. And then the hole, the blue cylinders, let me just make sure, 10 minus x squared. A hole, the blue cylinders, they have a radius of 10 minus the 3x, that y distance. And this is dx as widths, or pi 0 to 3, 10 minus x squared squared minus 10 minus 3x squared. Now, what you will find is, since you are squaring things, if you end up flip-flopping these things inside, it won't matter because you're going to be squaring it. But I don't want you to. I want you to really understand the correct height, the correct 10 minus, the correct top minus bottom. So keep things in a good order. But you will be getting the same answer if this was x squared minus 10, or if this was x squared minus 10. Okay? Now, we're going to revolve this region around the x equals 4 axis. All right. Watch this. X equals 4. All of a sudden, we're revolving this around a vertical axis. And here would be my reflection over there. Draw two sets of cylinders. One to get to the entire object, and then one that would be the hole. I'm just going to use a couple here so it doesn't get crazy. What would be the radius of this cylinder? This distance. A right minus a left distance. A right minus a left distance. And then in blue, here would be my hole. Here to there, there to there, there to there, there to there. And then right minus a left, right minus a left, right minus a left. Okay. Well, in this situation, the height is a very small change in y. So we got horizontal. I need to sum them up from a bottom to a top. I haven't even found the top. I know this is an x equals 3, but we should be able to figure out quickly that this is going to be y equals 9. So I need to sum these up from 0 to 9, a bottom to a top, to ensure that my height is positive. I got pi. Let's go to my outside r's, my entire object r's. 4 minus, well, this is not a y distance. I don't want 3x. I don't want 4 minus 3x because that would give me a y distance. I need an x distance in terms of a y equation. I need to solve this for x. X equals y over 3. That is a x distance in terms of an equation of y's. And then I'll subtract my whole, 0 to 9 pi r squared h. In this case, r, again, is a right minus a left. The right is 4, but the left is not x squared. That is a y distance. It's an x equals y equation distance. So I need to solve this for x. X is equal to root y. It's plus or minus root y, but this is the positive root y. The negative root y would be over there. Okay, we got that. 4. Factor out the pi. Factor out the dy. 4 minus y over 3 squared minus 4 minus root y squared. It's not r minus r being squared. Okay, the x equals -1 axis. What happens here when I revolve it here? Well, what we will find is that the outside changes. My cylinders that would represent the entire object are going to be going to the x squared curve. Where the radius is, a right minus left, is going to be the x distance here. So I need this equation, x equals root y. It'll be a root y minus a -1 or root y plus 1. Meanwhile, the whole is a right minus a left again, but the right is the x equals y over 3 distance, and then minus -1 or plus 1. Again, I'm using horizontal rectangles being spun, so we're talking about skinny heights, dy. The radius is a right minus left. So I need to sum these up from a bottom to a top to ensure dy is positive. I got a pi, a right minus a left. Here's my red ones. The right is the root y. The left is the -1. That's plus 1. And then I'll subtract 0 to 9, the pi. The right in blue is the y over 3. The left is the minus -1. Okay, more of the same. This guy rotated 4 ways. Okay, so x equals -1. I got this. Not great. Red cylinders. Look at that. Blue cylinders. What is the radius of the red cylinders? The radius of the red cylinders is 4 minus -1, or just 5. The radius is always 5. What's the radius of my blue cylinders? My blue cylinders are going to be this x distance. This would be a x equals y squared distance minus -1, a right minus a left. Okay, so I have pi. X equals 4 intersects with root x at y equals 2. I need to go from a bottom to a top, so I'm going 0 to 2. My red radiuses, my outside radiuses is 4 minus -1, or just 5. dy is the skinny heights. I'm subtracting 0 to 2 pi. The inside would be x equals y squared distance minus negative 1. X equals 5. Let's draw it up here. Here's my region, spun to the right. Here's my axes. This might help us. Okay. Here are my red cylinders. Here are my blue cylinders. Here's my red cylinder's radius. It's going to be a 5 minus a left. The left is going to be the x equals y squared. Blue cylinders inside, it's going to be 5 minus 4 consistently. So it's going to be a radius of 1 consistently. All right, so I got 0 to, this is 2 pi. Outside would be the 5 minus the y squared. The inside, dy, is the heights. The inside is the 5 minus 4 squared, or just 1 squared. Y equals 3 and y equals negative 3. Okay, here we go. Y equals 3, so it's going to be above. Here would be my reflection. Here are my red cylinders, which will always have a radius of 3. This line. That would cover the entire object, and then the whole. These will all have a radius of 3 minus. We can go back to y equals root x. It's a y distance. It's a y distance in terms of an equation of x's. All right, so we got 0, 2. We're going from left to right. We're going all the way to x equals 4. This is from 0 to 4, left to right. The outside r's are always 3, or 3 minus 0. The inside r's, and dx is the skinny, the width is now dx. The inside, the whole, is going to have a radius of 3 minus root x. That's a y distance in terms of an equation of x's. If I revolve this around negative 3, let's just write out the other option. Factored out the pi, factored out the dx. In parentheses, we'll have an r squared minus an r squared. Blech. Just went ahead and squared 3. Y equals negative 3, so I got the region. That's x equals 0. Here's y equals negative 3. Here's my region reflected. Here's my outside. The top minus the bottom. That's going to be the root x minus negative 3. And then the inside, blue ones, will be 0 minus negative 3. Or just 3. Kind of see. So I got 0 to 4 pi. Outside is root x minus negative 3 dx. 0, 4 pi. Inside the blue cylinders, just give me 3. Okay. You got to understand this conceptually. You have to understand the picture. I don't want us to try to take shortcuts. You will not have a good time if you do that. Okay. So this is a great one. Great example here. Find the volume of the area rotating the different axis. The y-axis I say is easy because it is easy. You know, if I revolve this around the y-axis, I just have an object. I'm just going to have a this object, and I just have red cylinders. I don't have any blue cylinders. I don't have any holes. The red cylinders all have a radius. The radius is going to be this x distance. It turns out this x distance is the same as the y distance. So I'm summing them up from a bottom to a top. That's 2 to 10 of pi r is 10 over y squared. Boom, easy. The x-axis, I say, is not as easy. Why? Well, first of all, we'd have a hole. That's one thing we have to worry about. The second thing is the following. If I start drawing some red cylinders, I see that the outside has 2 different tops. I got this top, which goes to the y equals 10, but then all of a sudden over here, I have this top, which goes to the 10 over x. So for the outside, I need 2 intervals. Now, I got to figure out what this x-coordinate is because I have vertical rectangles. So it's not 2 to 10 anymore. It's going to be 0 to when y is 2. This has to be 5. You have to figure that out. 0 to 5. But it's not 0 to 5. I have to go to this first intersection here, which will be x equals 1. When y is 10, x has to be 1. I have to go 0 to 1 of my outer radiuses being squared. And then I also need, this is with respect to x, because there's skinny widths. And then I also need from 1 to 5, my new outer radiuses, my new heights. That's over 10 over x squared. Those are all of my red cylinders here. And then I'm going to subtract the volume of the hole. I say outside. I like to say entire object. Sometimes I say object. Sometimes I say outside. The volume of my hole is right here. It's going to be consistently 2. I can go from 0 to 5. It doesn't change. It's always going to be 2. That's 2 squared. Okay, that 2, always the case. All right, so same deal here. X equals 4. Well, this is x equals 2. So revolving this around x equals 4, I'm over here. That means this is the inside, and then the curve is the outside. Since I'm revolving it around a vertical axis, I need horizontal rectangles. Just drop 2. Being spun, creating horizontal cylinders. And then I need the hole. So I do have a hole. Let's go with the red ones. I got this x equals 4, and this is an x distance. This x distance is x equals a y squared distance. Okay, so from a bottom to a top, to ensure dy is positive, 0 to, where does 2 minus x and root x intersect? It's going to be at 1. The square root of 1 is 1. 2 minus 1 is 1. You could also set the equations equal to each other and solve, but that's a little trickier actually. So from 0 to 1, the red cylinders are 4 minus y squared, and I'll subtract the blue cylinders, 0 to 1. That'll be 4 minus add, solve for x, this is x equals 2 minus y. It's the same thing. Just make sure you put that in. I put the pi's on the outside. It doesn't really matter. You can simplify this. This should be a plus, and this should be a 2. You can also simplify in here if you want to. There's no reason why this doesn't have to be simplified and this does. Okay, y equals 4, not as easy. It's not as easy. So I got the root x, the line, the x-axis, y equals 4 creates this rotated region. So I got an outside. The outside is consistently a radius of 4. Okay, so that's easy. So I got the volume of my object. My entire object is going to be pi. I got to go from left to right, so 0 to 2. Of my r's, which are 4 squared dx. But now I have to subtract my volume of my hole. Well, when I start drawing some vertical cylinders, I notice a problem. They're going to change. The radius from 0 to the intersection at 1 is going to be using the y equals root x. So I need to subtract that. But that's just from 0 to 1, and that's just 4 minus root x. But I also have to subtract, or I could just like subtract the quantity of the whole. That's 2 different ways to do it. It doesn't matter. The whole on the right side of 1 is going to be going to the x equals 2 minus y, or the y equals 2 minus x. So I also have to subtract from 1 to 2 pi, and I have this 4 minus 2 minus x equation. So you can't really factor out things. You're going to have to leave it like this because your boundaries are different. So like I think up here, up here I did not. Yeah, you can't simplify this. You have to leave it like that. So this is why I kind of recommend students think about it this first way, because there's some situations where you can't use a washer. How many integrals do you need to find the volume of the area rotated around the x-axis? If I'm rotating around this x-axis, I need 1, 2, 3, 4. 4. I'll need these, those are 3, but then I need to subtract the blue ones, which will be holes. So 4, 3 to get the outside, 3 for the object, 1 for the hole. Revolving this around the y-axis, how many do I need? I need 2, and actually only just 1. 2 or 1. 2, 1 for the object, which will be going to the 7 minus y, and 1 for the hole. And since you don't have different boundaries, you can combine these two. It's going to be from 1 to 4 for both. The whole will be going to the x equals root y equation. All right, now we get into some free response. Write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated around the horizontal line, y equals 6. What's great is that they give you expressions for the functions. Okay, now you got to know which one's which. I get this -2 parabola, so that's got to be h, and this is going to be g. I've evolved this around y equals 6, and here is my line, which means the parabola is going to be on the inside, and then the cosine guy is going to be on the outside. Something like that. Red cylinders right here, going to the entire object. Summing them up from 0 to 2. Blue cylinders going to the whole. So I could have either, going from 0 to 2, there's skinny width, I'm going from left to right, pi. My red R's are 6 minus G. Don't write the equation out. Whew, that's nice. Subtract, my blue R's are 6 minus H. This is good. Or 0 to 2, pi is factored out. Outside radius squared minus inside radius squared. There is an integral expression. I assume they're going to accept both. It says an integral expression. Here's an expression with an integral. I don't know if they mean like integral expression means you have to have one integral. Provide both, you know, can't hurt. All right, y equals -2. So y equals -2 is down here. When I revolve this, it really stinks that they don't give you much room to kind of see. But when I revolve this, you can see that this, the curve is going to be on the inside. That's the F curve. The line is going to be on the outside. So they're asking you to find the volume. So you'd have to use your calculator. But I'm just going to write it out. Assume you guys can use the calculator. Then the inside goes to this curve. All right, so this line is y equals -2. Oh, you know what's unfortunate? They didn't give me the intersection. So I'm going to do some work here. How long does this video take so far? Yikes! Well, it's an important lesson. You got to practice. X to the 4th minus 2.3 x cubed plus 4 intersects with y equals 4. So I can calc that intersection over there. 2.3. Thanks, guys. Okay, so red cylinders, 0 to 2.3 of pi. My R is 4 minus -2. How do I know that? Well, look, I'm going all the way up to 4 for all of these red cylinders. And then top minus bottom, 4 minus -2. Subtract 0 to 2.3 pi, my blue cylinders, go into that function, f of x. So I got f of x minus -2 dx. And then you have to type that into your calculator. This is an example of like when simplifying is kind of quicker and easier to do, because after you factor out the pi, you just have one integral from 0 to 2.3 of one r squared minus the other r squared. So the first r squared is 6 squared. That's 36. I mean, I should just type 36. The other r squared is f of x minus 2. So I'm going to put this in parentheses. f of x. Ah! Fine. Fine. There you go. R squared minus R. Do that. Let's go. Squared. Minus -2. So +2. That turns into a +6. Squared. Dx. 98.867 or 868. Done. Right, but did not evaluate an angle expression that gives the volume of the solid rotate around the line y equals 4. You get to the point where you've done enough of these and you're like, yeah, boom, outside, outside, inside, inside. I got it. And like you could, if you can see things visually, maybe not have to draw it. But that's just me. I've done a lot of these. I would not recommend doing this unless you really know what you're doing. I'm going using vertical rectangles, spun, infinite sum of them, pi. The outside is the parabola. The radius would be the 4 minus the parabola. Then the inside is going to be 4 minus the cosine function. If you don't know where this comes from, you are to draw the picture, obviously. I don't know where I was going there. Obviously, you can factor out the pi. Outside r's squared minus our inside r's, our holes r's squared. These are all horizontal lines, which you find is crazy. 0 to 1/2, that's our x distances. We're revolving on y equals 1. That means the x cubed is going to be the outside. So I got 1 minus the function is going to be the outside radiuses. And then 1 minus the sine function is going to be the inside radiuses. Y equals 7. This is 6, 7. I'm going to have a hole again. The outside is going to go to the 2 root x. So I got 0 to 9. That's a left to right. So the outside is going to be 6 minus 2 root x. And then the inside is going to be the 7 minus the 6. Oh my gosh. Wrong. 7 minus 2 root x. 7 minus 6. Okay, if you don't see where this comes from, draw the picture. I'm happy to show you. But yeah, this is a doozy of a lesson. You really have to understand what's going on. Good luck out there.